Alright, so in this problem, we are told that water is being pumped between two reservoirs with the given information: a mass flow rate of 2750 kilograms per minute, a Darcy friction factor of 0.02 in the pipe, an internal diameter of 150 millimeters, and the length of the pipe, which is 55 meters. We are asked to determine the frictional head loss over the length of the pipe. Now, in order to determine frictional head loss, you can apply this formula, where the major frictional loss is equal to the Darcy friction factor times the length divided by the diameter times the velocity squared divided by 2g. This velocity squared over 2g term is also known as a velocity head. So we know the Darcy friction factor, F. We know the length of the pipe, the internal diameter of the pipe. We don't directly know the velocity. We also know the gravitational constant in this case. So in order to determine the velocity, we can assess the definition of the mass flow rate. M dot is equal to rho times the flow rate for an incompressible fluid, or applying the continuity equation, this is equivalent to density times velocity times the cross-sectional area. So velocity then is equal to the mass flow rate divided by density times cross-sectional area. The area is a circular cross-section, so it's pi by 4 d squared, or pi by 4 times 0.15 meters squared. If I calculate that, it'll be 0.0177 square meters. The density we can assume to be 1,000 kilograms per cubic meter. This is water. So now we can calculate our velocity. Velocity is equal to the mass flow rate of 2750 kilograms per minute. Let's go ahead and convert that to seconds. So 1 minute is equal to 60 seconds divided by our density times our area So our velocity is equal to 2750 clear it, 27, was it 27 or 22? It was 27. 2750 divided by 60 divided by 1000 divided by 0.0177. This is going to be 2.59. Let's just check my units. The minutes cancel. Kilograms cancel. this square meter cancels 2 of those, so we have 1 meter here, 1 inverse meter in the denominator. So overall, this will be in meters per second. Now that we have our velocity, we can determine our frictional head loss directly from the formula. HF is equal to F, which is 0.02, times the length of the pipe divided by the distance of the pipe. The length of the pipe is 55. The diameter of the pipe is 0.15 meters. Times the velocity squared, 2.59 meters per second squared, divided by 2 times 9.81 meters per second squared. And checking our units, we have meters squared per second squared divided by meters per second squared. So we're going to end up with just meters, which makes intuitive sense for head loss. So if we calculate this out, 0.02 times 55 divided by 0.15 times 2.59 squared divided by 2 divided by 9.81. So our frictional head loss will be approximately 2.5 meters. Thanks for watching.